All right, welcome everybody to the last parts of the notes. This is the 8.4 video notes, potentially part one if we can make it through. That much wasting time, let's get to it. So, 8.4, the last section of notes for Unit 8, mostly deals with square root functions. And if I write up the parent function y equals, or you could even put an f of x, it doesn't really matter. But y equals the square root of x. All right, this is the basis of where we're basing this square root function on here. All right. Now, with this parent function y equals square root of x, all right, so if we look at filling out, like, say, an XY table for this, all right? Well, the lowest number I can go is 0. The only number I can plug, the lowest number is 0. And if I plug in 0 for x, again, that's just the square root of 0, which is just, well, 0 for y. And I can't go lower because, again, I don't want negative numbers in my square root sign. So I have to go 0 and positive numbers. And if I look, well, it's a square root. So let's say if I plug in a 1, the square root of 1, well, that just gives me 1. So what if I plug in 2? Well, the square root of 2 is kind of an ugly number. So what I want to do is I want to try and find numbers that to plug in for x that get me out nice numbers in the square root sign. And if I'm thinking, let's say, in terms of perfect square, my next perfect square would be, let's say, 4. And if I had to plug in 4, square root of 4 would be just 2. Let's see, go to my next perfect square, would be the square root of 9. If I plug in 9 for x, square root of 9 equals 3, so I would get 3 out. All right? All right. So we got our x's 0 through 9 plugged in here. We got our y chart set out here. Again, you don't have to do these exact x numbers. You could plug in, like, say, 2, 3, or even 5 or 6 for x, but again, you're going to get really ugly decimals, and I think we're going to try our best to avoid those. So if I go about graphing these, all right, so if I graph 0, 0, it's about right there. 1, 1's about right here. I go over 4 up to 2 for 4, 2, and then 9. I don't really have a 9 here, but let's go about 9. So right to about there. So it's looking like that. All right, so that's kind of what my square root function kind of looks like. Now, a couple things for the parent function, just kind of looking at it. So first of all, vertex. All right. So what is the vertex of this squared function? Well, it's essentially, where does the graph start at? What's the point of origin for the vertex? All right. And it just so happens that in this problem, the graph starts at 0, 0 for the vertex there. All right. So it starts at 0, 0. All right. Again, most of the times when we think of vertex, it's looking something like this. But in this case, it's essentially a starting point, and it's going to look something like that. Or as we'll see, it might even look something like this, but we'll get to that in a second. Domain, all right, what are my x values? Well, if I'm looking at over here in my table, or even if I'm looking at my graph here, my domain starts at 0, and I can plug in 0, and it goes, and if I look at my graph, I continually keep going this way, this way, this way towards positive infinity, all right? So what my domain is going to be is it's going to be bracket 0, this bracket, because I can plug in 0, comma, infinity with a parenthesis. Again, I always have a parenthesis with the infinity. Range is dealing with the y, so I'm thinking about kind of going up this time. I start at the y value of 0, so my start at 0, plug it in, bracket. And then even though it looks like this graph's kind of plateauing off, it's still going to continue up. All right, it's just going up very, very slowly, but it's still going to be going up. So the range is 0, bracket 0 to infinity, okay? Okay, so try and get through some of this stuff here real quick. In fact, I'm going to pause the video here real quick, and then we'll go through it. Okay, so I wrote out some stuff here just to kind of save us some time. If you want to write this stuff down, you can. I'm going to briefly go over it. So the general form of square root graph, y equals a times x minus a square root of x minus h inside plus k. All right, so kind of like how we dealt with the quadratic form of the vertex form of a quadratic before. This h and k is actually our vertex. All right, and it's actually, again, it's opposite the sign in here. So if it's minus a sign in here, the number is going to be positive. The thing outside is the same sign, okay? Now the A outside here, if that's negative, again, it opens down. Now there's a couple, now opening up and down is kind of different for a square root function. Again, a square root graph, if it opens up, just like what we saw before, it's going to look something like this. If it opens down, it's actually going to basically kind of be a mirror image. So basically pretend like this is looking in the mirror. It's like this, shapes down just like that. All right, so it's basically kind of looking in the mirror, kind of through the x-axis there. I kind of wrote that down here. So down here, let's identify the vertex, and I'm going to identify whether or not it opens up and or down. So this one right here. First of all, I know that this is going to open down because I got this negative right. Darn it. Got this negative right here. All right, so I know it's got to be something that looks like this. If I look at my vertex, positive 6 inside, negative 5 on the outside. That means I'm going to have negative 6 inside, negative 5 for this. All right, because again, first number inside the square root, opposite the sign. Second number is on the outside of the square root, same sign. All right, this changes, this stays the same. All right. If I look at this one's going to open up. Positive number on the outside. All right, even though it's a fraction, it's positive. I know it's going to look something like this. So look on the inside. All right. What's my x value? Look on the inside here. Negative 3. Inside changes, so that's going to turn into positive 3. Negative 7 on the outside. Outside doesn't change. Goes to negative 7. That's my vertex. Here we go. All right. All right. Going on here, let's go kind of some more complete examples. So I'm going to delete the slope here. We don't have to deal with that. So y equals negative 5 plus 2, square root of x minus 5 plus 2. Let's figure some stuff out here. All right. So automatically, all right, let's find the vertex. That's the first thing I want to find. Get vertex, 2 points, x and y. X value inside the square root function here. It's negative, it's minus 5, so I'm going to put a positive 5 opposite the sign. And then on the outside here, I have a plus 2 for my y, so it's going to stay the same as a plus 2. All right, so it's the same as a plus 2. Now, as we fill out our graph, what we're going to see is that filling out our XY chart, the first point I want to start with is 5, 2, okay? Because if I plug in any numbers that are less than 5, so like a 4, if I plug in 4, 4 minus 5, that's negative 1. I can't have the square root of a negative number in there. So I have to go 5 and up, all right? Now, there's a little pattern that I'm going to show you that actually kind of helps see the numbers that you want to plug in. So this, I start with 0. That's kind of my base term right there. So all based on the x's, all based on the x's. From my original x's, I'm going to add 1. So for this x, I'm going to add 1 and plug that in. So if I add 1 to 5, I'm going to get 6. If I plug in 6, I do 6 minus 5, which is the square root of 1, which is 1 plus 2. I get 3 out of that. All right. For my next trick, or for my next one, for the original, this is all based on the vertex, the x value of the vertex. I'm going to add 4, all right? Just add 4 to this and add 1 to this. I'm going to add 4 to this. So 4 plus 5, that's going to get me 9, all right? So if I plug in 9, for 9 minus 5, that's the square root of 4, which is 2, plus 2, that gets me 4. And if I look, it looks like I can't really go any further on my graph here, so that's basically it, okay? So what I'm going to do, let's go ahead and graph this. 5, 2, I'm going to go to the right 5, 1, 2, 3, 4, 5, right here, up to 2, which is about right here. 6, 3, so 6 is right here, go up to 3. 9, 4, 9's about right here, and I'm going to go right up to there. It's going to look something like that. All right? If I'm looking for my domain, all right, let's look at my x value in my vertex. It's 5, all right? So I know in my domain, it's going to have the 5 here. Now, the domain is always going to look like this. Bracket, x value of vertex, comma, infinity. That is always your domain. It's always the x value of your vertex. The range is a little bit different. So, first question I ask myself for the range. Opens. Where does it open? This time it opens up, So it's going to infinity, all right? And then when I find out that it's going to go to positive infinity, which again always goes on the right side of my interval notation, I just find my y value of my vertex, this 2 right here, and I plug that in here with this bracket right here, with this bracket. All right. All right, so going through this one real quick as well. All right. First off, see that's negative. I know it's gotta look something that looks kind of opens down like this. All right, so if it's negative, it's got to open down like this. My vertex, two numbers, x and y. It's right here. There's plus 3 on the inside of my square root. Inside, that deals with my x. Plus 3 means it's got to be a negative 3. Change the signs. Change the signs. Negative 6 on the outside. On the outside stays the same. So with the y, it's going to be negative 6. Remember, that negative 3, negative 6, that's the first point that we're going to go here, okay? Now, using my little pattern that I showed you, all right, what we're going to do is we're going to add 1 to this original x value. So it's going to be negative 3 plus 1. That gets me negative 2. I take this negative 2, plug it in for x here. So I got negative 2 times negative 2 plus 3 minus 6. That gets me negative 2 times square root of 1, which is just negative 2 minus 6. That is negative 8. From there, I'm going to add 4 to my original. So 4 plus a negative 3, not 4 plus this negative 2, 4 plus this negative 3. That gets me 1, all right? So if I plug in 1, square root of 1 plus 3, that's the square root of 4, which is 2, times negative 2, which is negative 4, minus 6 is negative 10. We got one more I'm going to do. The next one, I'm going to add 9 to the original. So I'm going to go to the original and add 9 to that. So 9 plus negative 3, that gets me 6. I'm going to plug in 6. Going to do this over here. 6 plus 3 is the square root of 9, which is 3, times that negative 2, which is right here. And then minus 6. Negative 2 times 3 is negative 6. Minus 6 gets me negative 12. All right. If I go ahead and graph this, go to negative 3, 6. Negative 3, which is right here. Down negative 6, which is right here. Negative 2, negative 8. Negative 2 is here. Negative 8 is kind of way down here. I'm kind of don't have a whole lot of room down here. Negative 1, we'll go 1, negative 10. So that's kind of, I'd say, right about down there. And then 6, and about 12. So it looks something like that. Not a great drawing, but again, it looks something kind of like that. Domain, again, what's my x value? Bracket, x value of my vertex, negative 3, comma, infinity. Range, this one's a little bit different. Opens, it opens down. So you know that it's going to go to negative infinity. So for the range, negative infinity always goes on the left side with a parenthesis. Comma, what's the y value of my vertex? Negative 6 with a bracket. All right. So again, domain always has x value of vertex. Range has the y value. All right. Range has the y value. All right. Now the last couple bits here basically are dealing with transformations and how to write these out. So you either have 3 types of transformations you're going to deal with. You have either left or right, up slash down, or just write up slash down, and then reflect slash flip over x axis, all right? So left slash right, we kind of think of that as inside square root. This is on the outside, up slash down. And then flipped basically means I have a negative on the outside. So if I think translated left 5, up 3. Well, let's see here. So that basically means I'm taking my vertex going left 1, 2, 3, 4, 5, which is negative 5 spaces, and then I'm going to go up 1, 2, 3, plus 3. If I take my original square root of x equation here, y equals square root of x, let's see, left 5, left, that calls into left slash right, that goes on the inside with my x here, so x minus 5, that turns into plus 5, and then up 3, that goes on the outside here, plus 3, up slash down, that stays the same as plus 3, and it doesn't flip over, so that's the equation right there. Those are the 8.4 notes. Thank you for watching.